Welcome back. So we are looking at the last one where we want to solve and prove the sides if they are either isosceles or not. Because in the other one it was not, and the that is very important for you so to note this one. You can say the points L, M and N are 4, 4, negative 4, 1, and 1, negative 4 are the vertices of a triangle. Show that the triangle LMN is isosceles. So can we try to look at this if it is isosceles on that? That is our example 4. This is our solution. Let's try to sketch. I've got this is L, M, N, and point L is 4, 4, and point M is negative 4, 1, and point N is 1, negative 4. So we say that for it to be isosceles, for isosceles triangle, the two sides or the two lengths, the two sides must be equal in lengths. So want to prove that are the two sides having equal lengths? Can we start with the lengths LM? When you're getting lengths LM, series I will use our formula x1 minus x2 squared plus y1 minus y2 squared. So which becomes, do we know x1? According to LM, it is 4 minus 4 squared plus, then we go to 4 minus 1 squared. So what are we getting here? This is 4 minus 4, that is 8, and 8 squared, that is 64, plus 4 minus 1, it is a 3, and the 3 squared we are getting a 9. So we are getting 64 plus a 9, we are coming out with 73. So we are getting LM as root of 73 units. So also go to MN. Also prove MN. We still are going to say root of. We are using the same formula. Our x1 is negative 4. Can say negative 4 minus 1 the whole of it squared plus y1 is already 1 minus 4 squared, which becomes the root of negative 5 squared, that is 25, plus again 5 squared, that is the root of 25, which becomes root of 50, which is the same as 5 root 2 units. So we are also getting ln. We are going to use the same. So what is our L1? X1 is 4 minus 1 the whole of it squared, plus we go to 4 minus 4 squared. So we are coming out with root 4 minus 1, that is 3 squared, that is a 9. This is 8 squared, that is 64, which still becomes root of 73 units. Now you can see that length LM is the same as length LN. you can see that length LM is the same as length this one. You can say since LM, length of LM is the same as length of LN, which is equal to root of 73 units, then triangle LMN is isosceles. And you have seen that rule. But the moment you hear that the two sides are not equal, don't go ahead and conclude that they are isosceles. So for isosceles, the two sides must be equal. So that's what we wanted to look at that, as we are now going to embark to a new sim on it. We're going to look at the midpoint. So you're going to look at the midpoint. The midpoint between the 2 points. And so consider the line PQ with P x1 y1 and Q x2 y2 as shown below. If we have the point, this is P, this is Q, and I've got P as x2 comma as x1 y1, Q as x2 y2, and if I have here as a midpoint M, I can call it small p, small q. So how do we get that one? When you are getting the midpoint, M, you can say M is the midpoint, of the line PQ and is given by. So what happened to it? It means that it implies that the length of PM is always the same as the length of MQ. So if this one is the midpoint, it means that PM, the length of PM is the same as the length of MQ. So when you try to go ahead, you can try to look at the length of the x coordinate. It will be P. If you get the difference, it will be P minus x1, which is the same as the other side. You can say x2 minus a P. So if I try to make P alone the subject, what happens? You can try to correct like terms. P is a negative. When it becomes a positive, so you're going to have P plus P equals to be x1 plus x2. When the other one goes there, I've got 2P equals x1 plus x2. Make P alone will be x1 plus x2 out of 2. That's how we are getting point P. Equally, we have said that since the length of this one is equal to length of here, we're now dealing with y coordinate. We are going to have also PM is the same as MQ. So what is happening here? We're going to have y1 minus a q is the same as the other side. You can say y2 minus a q. So can you still correcting like terms? Bring this one or take this one there, or I can just, that is not y2, it is y1. You can start by getting a difference. You can say q minus y1 is the same as y2 minus a q. So can we rearrange? This one comes here, we are getting 2q, which is equal to y1 plus y2. So dividing out by 2, we're remaining with q equals y1 plus y2 out of 2. You can see these are the coordinates of P and Q. It implies that since M into PQ is the midpoint, of line PQ, then the midpoint is given by the formula M, which is the midpoint of those points, is given as, what was the point P? P is given as x1 plus x2 out of 2, comma, y1 plus y2 out of 2. So you have already seen, you have proved where it came from. So that formula is one which you are going to be using when we are busy calculating more examples which are related on how to find the midpoint of a given equation. So we have tried to derive it, and we are now coming to look at the examples applicability of it.